Today, let us see some more sums on Nyquist stability criterion. The open loop transfer function of a unity feedback system is given by G of S H of S equal to 5 upon S multiplied by S plus 1 multiplied by S plus 2. Draw the Nyquist plot and hence find out whether the system is stable or not. In this case, because of this S, the Nyquist contour is different. What is the Nyquist contour? Nyquist contour is contour C1. It varies from 0 plus to J infinity. That is C1. Then a semicircle of radius infinity from R e power j theta. R tends to infinity and theta varies between pi by 2 and minus pi by 2. That is the second segment C2. The third segment is from minus j infinity to 0 minus. That is the third segment. In this sum, because of this S, S is at the origin. That is 1 by S means a pole at the origin. That should be excluded because this Nyquist contour must be analytic. Analytic means it should not pass through any of the poles. That's why we have to exclude that pole. So draw a semicircle about that pole of radius epsilon. Similar to C2, its radius is epsilon e power j theta, as epsilon tends to 0 here. There is R tends to infinity, here epsilon tends to 0, and theta varies between minus pi by 2 to pi by 2. That is the difference. So this segment is called C4. We have to map C1, C2, C3, and C4 on the function G of S, H of S. So if you map this on G of S, H of S, what we will get, we have to see. So for that, the first step is we have to consider the mapping of C1. We have to consider the mapping of C1. C1 means omega varies from 0 to infinity. It is nothing but a polar plot. That's why we have to find G of j omega equal to 5 upon j omega plus 1, j omega plus 2. Modulus of G of j omega equal to 5 upon omega square root of omega square plus 1 square root of omega square plus 4. Angle of G of j omega equal to minus 90 for S. For this one, minus tan inverse of omega minus tan inverse of omega by 2. If we substitute omega, when omega tends to 0, the magnitude modulus of G of j omega tends to infinity. Angle of G of j omega equal to, if you put omega equal to 0, you will get minus 90. When omega tends to infinity, G of j omega, because there is no polynomial in the numerator, the only denominator polynomial, that's why it tends to 0. Omega tends to infinity, it tends to 0. Angle of G of j omega equal to 3 angles. This is minus 90. Omega tends to infinity means this also becomes minus 90. This also becomes minus 90. Therefore, minus 270. There is no numerator polynomial. That's why the polar plot, the plot for this is, it starts at minus 90, infinity, j minus j infinity. It starts at infinity and it reaches 0 at 270 degree. That's why the plot will be looking like this. When omega equal to, omega tends to infinity, it reaches here. Real part of g of gh, real part of gh. This is real part, imaginary part of gh. So that the plane is gh plane. The plane is gh plane. This is in s plane. This is in s plane. So now we did the mapping for C1. Now we have to do the mapping for C2. That is mapping for C2. Mapping for C2. C2 is what? C2 can be mathematically defined as, C2 can be mathematically defined as R tends to infinity e power j theta, and theta is lies in between pi by 2 and minus pi by 2. This is the definition for C2. This we have to substitute in g of j omega. G of j omega equal to, the magnitude is here 5 upon s. S means r e power j theta, r e power j theta plus 1, r e power j theta plus 2. If you take r e power j theta outside, what you will get is r cube e power j3 theta. Here 1 plus 1 by r e power j theta, 1 plus 2 r power e j theta. As r tends to infinity, here we have to include that limit r tends to infinity. Infinity. That is equal to this tends to 0. This is also tends to 0. This only this alone is there. R tends to infinity, it becomes epsilon, as epsilon tends to 0. Or you can put simply 0 e power minus j3 theta. Therefore, the angle varies from 3 times 90, that is minus 272, minus 272, minus 272 plus 270. It varies like that. So it is the mapping is like this. So anyhow, it is a point at origin, but its angle only varies. Its angle alone is varying. Therefore, its angle varies from 272 minus 272 plus 270. A point at origin. It is nothing but a point at the origin. Now mapping of C3. C3 is what? C3 means omega varies from minus infinity to 0 minus. So it is, the mapping is mirror image of mapping of C1. Therefore, what is the mapping of C1? Mapping of C1 is this. This is mapping of C1. it will be a mirror image, means it will be like this. This goes to J infinity. Now we have to do the mapping for C4. Mapping of C4. Mapping of C4. C4 means what? Epsilon, as epsilon tends to 0, e power j theta, theta varies from minus pi by 2 to plus pi by 2. Theta varies from minus pi by 2 to plus pi by 2. If you substitute here, g of j omega equal to as omega tends to epsilon e power j theta equal to 5 divided by epsilon e power j theta, epsilon e power j theta plus 1, epsilon e power j theta plus 2. So as epsilon tends to 0, this tends to 0, this also tends to 0. The only 1 by 0, this becomes 1, this becomes 2, 1 by 0. Therefore, 5 upon 0 e power j theta, or 5 by epsilon equal to infinity e power minus j theta. Theta varies from minus pi by 2. Theta varies from minus pi by 2 to plus pi by 2. Here, because of this minus sign, it is radius of infinity. The mapping is radius of infinity. Mapping is radius of infinity, and angle varies from plus pi by 2 to minus pi by 2. This is the Nyquist plot. This is the Nyquist plot. So, what is the Nyquist plot? Nyquist plot is this is for C1, segment C1 up to minus j infinity. This is for C3. This is up to plus j infinity. The mapping of C1. This is mapping of C1. Mapping of C1. This is mapping of C3. Mapping of C2 is a dot at C1. This is mapping of C2. Then this is mapping of this is mapping of C4. Its radius is infinity. It varies from pi by 2 to minus pi by 2. Its radius is infinity. Its radius is infinity. This is the mapping. So now we have to find where it intersects the real axis. To find that, let this point be A. To find the point A, that is intersection with the real axis, that we have to find. To find the point A where it intersects the real axis, we have to consider the transfer function g of j omega equal to 5 upon j omega plus 1, j omega plus 2. So multiply the complex conjugate on both sides, numerator and denominator. What you will get? 5 complex conjugate of this is 1 minus j omega, and for this 2 minus j omega. If you multiply this, this j will come here, minus j. If you bring this j numerator, you will get minus j omega multiplied by omega square plus 1, omega square plus 4. So this is, from this we can write minus j5 what you will get minus omega square minus 3j omega plus 2 plus 2. So what you will get upon omega square plus 1 omega square plus 4. If you bring equate imaginary part to 0 to get point of intersection with the real axis, because at this point uh, imaginary part of omega equal to 0, imaginary part of g of j omega, imaginary part of g of j omega equal to 0. That's why we are taking the imaginary part out and we are equating this to 0 minus minus j5 and minus omega square plus 2 equal to 0. Or omega square equal to 2 or omega equal to plus or minus root 2, plus or minus root. So for this we have to find modulus of g of j omega. Modulus of g of j omega 5 divided by omega root 2 omega square root of omega square plus 1 2 plus 1 square root of 2 plus 2, that is equal to 0.833. Therefore the point of intersection A equal to minus 0.833. A equal to minus 0.833. Therefore, the Nyquist plot doesn't encircle minus 1. Minus 1 is here. Minus 1 is here. It doesn't encircle minus 1. Therefore, n equal to 0. What is P? Consider this transfer function. Here n equal to 0, P equal to 0. Therefore, Z equal to P plus n, that is also 0. Therefore, the given system is stable for a gain of 5. The given system is stable for, we have to write given system is stable for the gain, static gain 5. What is the range of K for stable? That is range of K for stable is, here it is 0.833. If you divide this by 5, because we have to take K equal to 1 to find the gain margin. So, but K equal to 5 here, that's why we have to divide this by 5. Therefore, A equal to 0.833 divided by 5. How much? 0.833 divided by 5. 0.16. Therefore, gain margin equal to 1 by modulus of A, that is equal to 1 by 0.16, equal to how much? 6.2. Therefore, we can increase a gain of 6.2. Already it is 5. If the value is above 6.2, definitely it will be unstable.